Okay, thank you everybody. My name is Tomislav Drensky. I refer myself as Tom. I'm working for Socionext Europe, and I'm here today to give you an introduction about Socionext's Nessum solution. For people who are interested, I also brought some flyers, so whoever is interested, please feel free to take out one of the flyers. Next, please. So the agenda of my talk today is I will give a company introduction because I think many of you maybe do not know Socionext and what we are doing. Then I will talk a little bit about the Nessum Alliance and technology. So JP and Mitch today morning gave already a brilliant presentation and a very detailed overview, but maybe I just go back again to emphasize on some points which I see important to introduce or to recap again. Then I will talk about our Socionext solution itself. So we are introducing a chipset. We are one of the chip vendors of Nessum, and I will explain a little bit about that, and of course I will have a summary. So let's start with Socionext company overview. So the company name is Socionext Inc. It's a Japanese company. Our headquarters are in Yokohama in Japan. Our capital is around about 33 billion. And the start of business was 1st March of 2015. So people might think, oh, 2015, it's a very young company, do they know what they do? But to say the truth, actually, Socionext is a joint venture. So former Fujitsu Semiconductor and former Panasonic Semiconductor, they merged into a new company called Socionext in 2015. So basically, we don't have only 9 years of experience, we have more than 40 years experience in designing, development, and producing LSIs. Business description, if you look at the homepage, is design, development, and sales of system on chip. Okay? And of course, solution services centering on system on chips. We have worldwide around about 2,500 employees, and we have basically 6 big group companies. So here is the worldwide map of Socionext. You can see the companies. So of course, headquarters is here, as you see, in Japan. We have many locations in Japan. Headquarters is in Yokohama, but we also have several companies in the ASEAN region, like Technology Pacific Asia, or Shanghai, or Taiwan, or Korea. We do have subsidiaries in America, so one in Milpitas and one in Detroit. And I'm coming now from the European side. So we have a headquarters in Langen, that's very close to Frankfurt. And we have another subsidiary in Neuwied, and this is very close to Munich. Me personally, I'm located in the UK, because this will show you next slide. Yeah, please, next slide. So this is the location in Europe. So basically we have like the headquarters in Germany, in Langen, which is close to Frankfurt. We have sales and business development, we have technical marketing, and all the corporate functions in there. And we have also another office in Berlin, close to Munich, where we do the automotive solution team and design centers. And we also have sales and business development and supply chain management there. And we do have, as showed there at the bottom, in the corner, France, Italy, UK, so we have some small offices there, or home offices there. So I'm, like I said, located in the UK. Next, please. Okay, for business scope, what we are doing in Socionext, we have basically 5 big business units. So one is, for example, automotive, where we do advanced driver assistance systems or human-machine interfaces. We have a big group doing data center and networking, looking into optical transport networks or data center applications. We do have an industrial application unit, where we have looking into automation and office solutions. We have a smart device business unit, where we look into camera application and augmented or virtual reality kind of solutions. But here for the EU Day, we are talking about this business unit, which is called IoT and radar sensing, and there is a dedicated division handling Nessum. Okay, thank you. So that's about my company. So now a little bit about Nessum Alliance and the technology behind, please. So we talked already about this. Basically, you should be aware of it, but just to recap again, like Mitch already explained, Panasonic had the idea of having HDPLC in 2006, and they did make then the company in 2007 in an alliance. At that time, they were only focusing on power line communication using networking cables, right? But since then, many things changed, especially the last several years. There were huge advancements, and now we are focusing on not only power line communications, we use and check on communications via any media. So we said any media communications. So it could be then handled via any kind of wire. It could be flat cable, twisted cable, coax cable, but also traditional power line cables. And as already mentioned today morning as well, it was really even extended now to wireless applications, or they call it air, right? So where you have short distance wireless communications via air, or as was shown today morning, using underwater applications. Important to mention is, like I said already also last year, the Nessum Alliance was formed. And important for me to say is that there's a complete ecosystem available. So as it was mentioned, there's a technical working group, there's a standardization working group, there's a marketing working group, and they're all working together. And there's LSI vendors, and there's product vendors, and they're all working together to, also with service operators, to get a solution to the end customer. And this solution is interoperable. It has a complete ecosystem. There are several vendors available, and that makes it a really unique broadband power line communication solution, which is available right now in the market. Next, please. This is just a quick overview, because we also talked about the IEEE standard today morning and how it started. So basically, in 2010, there was an IEEE 2010 established, but there was not much traction at that time, and there was also a lot of complications or challenges using that. But as you can see, recently, especially starting with the 1901A and B and C, which was also explained today morning, many new features were included, and the whole solution was heavily advanced. And now there's a lot of new features like long range or very high speed. You have many number of channels, like 15 channels. You can have different PHY rates, like normal mode, half rate mode, quarter rate mode, but also like double or ×4 mode. And most important, because nowadays we talked also today morning about cyber security, right? And reliability. So with the new standardization, we have now also features of secure network, and we implement IEEE 802.1x for authentication, which is crucial for the future to deploy and have a secure networking infrastructure. And as said, communication over any wire and wireless and air underwater is also included there. And as you can see, every several years there's a new publication, and this is still going on. This was also showed, JP showed this nice slide. Now we don't have only the half mode and quarter rate mode, it will be even further extended and further optimized. And as PPCAG showed today morning, there is some very interesting band they would like to have to be implemented. So this is still ongoing, and there is still more improvements to come in the future. So it's a really also future-proof solution. Next, please. Okay, this is just a quick slide to show what we see as Socionext where we implement our chipsets. So basically we see it in power line communications or in comms cables. So it could be like a coax cable or just any cable. And we see the benefits of the high security, having also the AS128 and the modulations in there. We see the benefit of the high-speed comms, and of course reliability and stability, which comes with the Nessum solution. On the right side, I showed now VS known technologies. Of course, Ethernet is very, very dominant, and also Wi-Fi. Everybody is using Wi-Fi. And I don't want to say now that Nessum should replace these solutions, because they have their own benefit in their own sake. But I think, as it was also mentioned before, they could coexist, help each other, right? And wherever there's a limit in Ethernet, like for example, short distance or something, I think Nessum could help out bridging the gap, as we also said today morning. Next slide, please. So this is just an idea, right? So where I also wrote down where is the last mile? So basically, this was just a setup we did. So there's a laptop on the left side, and there's, for example, a speaker or video camera on the right side. Normally nowadays, people will just use an Ethernet cable, which is available somewhere in the office, or they use connected via wireless, right? So what is going to happen if, for whatever reason, these connections are not available? So having a Nessum is implementation is a really simple plug-and-play solution. So you could have, these are two of our EDKs, which I show here and here. So you can just use on the left side, connecting the PC to the Ethernet, to our chipset. And on the other side, use our chipset and connect it to the speaker or video camera, whatever it is. And you just use any wire. In this case, we just use the socket and connect it to it. And yeah, you could have then a connection. And then I said, like I said, what is the means? Is it could be, Nessum could be a coexistent technology. It could be a backup system. It could be a secondary system, right? And yeah, it is a bridging and supporting technology, I think. So that's what we think our IC is going to do. So about our solution itself now, Socionext solution. So top right, that's our chipset, SC13208 is the name of it. And for applications areas, thank you again. There were already some very nice use cases explained there. And there is, of course, many use cases. And application areas are, as also was showed by Mitch this morning, like the whole smart city and smart environments like smart city, smart building, smart factory. Could be process automation, robotics, anything industrial with cameras or security, any equipment control. And of course, what we are also very much focusing on is everything with smart metering, smart meter gateways. But it could be also street lights or smart parking, EV chargers, AVAC system was explained already today as well, and any kind of energy control and management. I mean, there's so many possibilities where Nessum could be used. So that's the target solutions for us as Socionext at the moment. So we are now looking to enable data and communication in general, or using it as a secondary solution or a backup solution. Then what we see is that it's an easy, reliable monitor, controlling, switching of any device system. And key point here is that you can use existing cable and existing infrastructure networking. That's like key use. You can save so much money by using existing networking infrastructure. Possible use cases where we're working heavily and work and support is smart meter and smart meter gateway solutions. And also we look very heavily into IoT Society 5.0 products, especially into smart buildings, for example. But again, everything what is tunneling, shafts, pipe, wherever wireless cannot really penetrate, I think Nessum would be a brilliant solution to support and get the last mile done. Please. Okay, this is our chipset and what it promotes or what it enables. So at the right side you see the old legacy solutions for HCPLC 1, 2, and 3, and as you see, there's no much change actually. It's of course the chipset became maybe smaller, more power efficient, but in terms of features and enabling new kind of solutions, yeah, it did not do that much. But with this new Nessum solution, with the IEEE 1901-2020 and the ITU-TG 9905, you can see many new channel functions were introduced. I already said we have the standard mode, half rate mode, quarter rate mode to extend the distance. I will explain this later again in more detail. Then we have basically a bandwidth of 2 to 28 megahertz, which is now with 1901C extended to 31.25 megahertz. Fire rate for our chipset at this stage is 250 megabits per second max. And then, of course, what is very important is the distance. So with mode 1, you can reach around 400 meters, and if you go to quarter rate mode, you can extend up to 1000 meters. And as explained earlier, we have the multi-hop functions, right? So we can have up to 10 hops as repeaters and amplifiers. And then, of course, if you have 400 meters, you can have 10 times of the length, so you would reach up to 4 kilometers. Or if you would say you go to a quarter rate mode, you could reach actually 10 kilometers, which I think no other power line communication, broadband power line communication, can achieve at this stage. Maybe some fun facts, maybe they were mentioned already today morning, but just to repeat. So we use the wavelet OFDM. As you all know, maybe it forms deep notches, and it has a very high efficiency transmission. And based on the signal to noise ratio, you can have then a pulse amplitude modulation between 2 or 32 to get the data transmission done. We have basically 7 bands, the table I will show later on, and each of them has 512 carrier. And here, very important to mention it, that we have flexible programming and notching of these carriers. And that's very important because different countries have different regulations. And there are selected bands which you are not allowed to use. So just by programming it, you can notch out these bands and you can use it wherever needed. Or if you know in a special application, industrial environment, that you have a disturber generator having a spike always at 10 megahertz, you can just say, okay, let's just notch this out and not use it to don't disturb our system. The cell size, I think this was mentioned today morning, is basically up to 1024, but that's actually a theoretical limit. It depends on the MCU size and yeah, how powerful the processors are to have a number like that. And with that, of course, you can have long range, or you can have wide area networks. This was also explained today morning. You can have complete network architectures using this kind of solution, so it's really great. And as far to my understanding at this stage, if it comes to coverage, our broadband power line solution is has significant improvements, and it's at this stage the best broadband power line solution available on the market. Next, please. This is a brief specification just to get you an idea what our chipset look like or what the features are. We have a CPU, which ARM Cortex inside. We have all the basic interfaces needed, SPI, UART, RMI. We also are compliant with BACnet or LoanWorks or this kind of stuff. Of course, the Nessum core is inside, which supports the 2x. But our chip does not support the 2x and 4x, but it does support the other modes. We can have max 10 kilometer, like I said, with the 10 hops. Power supply, we have only one single power supply of 3.3 volts, so it's really very easy. Just connect it to this 3.3 volt and everything is up and running. We have a very low power consumption of 200 milliwatts typically, and also our package is, I think it's the smallest chips that's available at the moment. It is only a form factor of 7 × 7 millimeters, so it's very, very small. And of course, temperature range -40 to 85, that's industrial standard, so we comply to all the industrial standards as well. Next slide, please. So this is maybe just again a recap of what was shown today morning a little bit. So top left we see the band divisions, so X1 the full mode, or we can have the half rate mode where we select X2 or X3, or you have the quarter rate modes. And as it was said already also today morning, on the right side you see the attenuation. If the frequency goes higher, attenuation goes worse, of course, and also signal to noise ratio will be heavily impacted by that. Having an X1, as today morning explained was already, you can reach 400 meter with 5 megabits per second line as a limit. And if you want now to extend the reach, please next, then you could switch from an X1 mode to an X2 mode. So what are you going to do? You basically half the bandwidth. As you can see, you just use the front end, or you could use the back end. Depends on your system or what requirements are. But in this case, you can see, just as an example, good signal to noise ratio. So you would use, of course, wherever your good signal to noise ratio is. And with that, you put all the 512 subcarriers into the smaller band. And with that, you can then extend the reach, for example, here from 400 to 700 meters. Why that's important? Basically, the most important fact for people who need long distance is to establish the link. That's important. And in order to establish the link, you need like at least 10 subcarriers kind of to establish the link. And then if you, of course, divide the bandwidth into half, you have much more chances that you have much more subcarriers, and you can have 10 subcarriers which can establish the link to get the data throughput done. And the same applies then, next slide. if you go, for example, for quarter rate mode. You can choose then again between X4, X5, X6 or X7 mode, depending on the noise ratio. And then you again squeeze everything into the lower band, and you can then extend also the reach again. Like I said, you get that with that, you can establish a link, and also it's very robust and very reliable, because that's also very, very important for, especially utilities companies, right? That they have a very robust and very reliable link. Next, please. That's our offering. So as you can see, of course, we have a chipset. We have, of course, all the development documentation with it, specification, guidelines, evaluation. We have also a reference design if you want to engage with us. So we can give it to you. If you don't want to start off with a chip and a reference design, we have evaluation kits. So it comes then with a graphical user interface you can install on laptops. And just by plug and play and using the features of the graphical user interface, you can test the chipsets, connecting any kind of cable in between the two devices or many more devices, have a small network, and play around and see if it's suitable for your environment, yes or no. Next one. Yes, so the evaluation kits, of course, are available already, also for the chipset itself. It's already mass production, and it's already started shipment, and of course you can get then all the documentation, everything what is needed along with it. So maybe a summary then, at the end, just quickly to go through everything in recap. So we think that our solution is unique. So our SC1320A has a very small package size, has a very low power, and is a state-of-the-art device. It conforms with the latest IEEE standard, right, and ITU, and it's the first worldwide device using the Nessum evolution. It is easy to control, and it has a high security encryption for data transfer, which is nowadays, like I said, becoming more and more important, especially looking at cybersecurity. Then it enables long-distance communications if this is needed, and it has the multi-hop functions, right? So, and you can connect. Here it's just 1,000 nodes because it's easier to read. Else, our chipset does have all the necessary IoT device interfaces, so UART, SPI, Ethernet, MAC, RMI2, and also supports existing industrial protocols. Important, this solution simplifies wiring work, reduce cost, that's always important, and like I said, it could use existing cabling infrastructure. Last but not least, Nessum is the best broadband powerline solution available to the market with multi-vendor access, which also all the other solutions out there, they claim that they are multi-vendor, but they are not really. They have multi-vendors, but they are not interoperable, and that's the problem. But in Nessum, with the alliance and everything, we really have a complete ecosystem which is also interoperable, which is really important, I think, to mention. So that's why I wrote at the end. We have a major solution with National Alliance, which enables worldwide ecosystem and interoperability of Nessum devices and systems with different vendors, and many different customers focusing on IoT and the Society 5.0. And it's also very suitable for the critical and secure infrastructures in the energy sector. Thank you very much. I think at least. If you have any questions, please let me know or catch me later on.
Okay, thank you. Thank you very much, Tom.